So welcome to my channel, people. And so we will just implement our code on derivatives in this lecture. So at first we'll import some packages, and first package is NumPy package, which will handle our matrix calculations in different parts of our code. So NumPy package is imported as we'll just type import then NumPy, and as np means we'll just use the alias np for this NumPy package. We don't have to write NumPy every time, we'll just write np. And we'll also import a typing hint called callable, and we will also import matplotlib.pyplot as plt, and we'll just use this matplotlib inline code. This code will help us to plot this plot the this graphs inline in Jupyter Notebook. So we'll just press shift enter, and yes, it has run quite smoothly. So right now we will be using the derivative of sine, and I'll show you how to use that. And so first we'll learn how to write functions. So for writing functions, we'll write def and give the name of the function, which is deriv, and we'll write func. Okay, we'll just write func. Func is a function, and this is what is the callable one. That is, it can be called np.ndarray, np.ndarray. So what this means is that function is a callable type, which means this function can be called. That is, it can be given some input, which is, and this is the input which can be given into this func, and it will also give us an output which is an n-dimensional array. This np.ndarray means it is a multi-dimensional array which can be given to us. That is, this is a matrix. It can be, this is really a matrix, not really anything like fancy things. So this functions is a callable type which can be called. It takes some multi-dimensional matrix, and it also gives out us a multi-dimensional matrix. So this is the input and this is the output. It's very simple. So we'll also need inputs for, this is the def by which we say that this is the function, this is the name of the function, and all these are really the arguments of the function. So what this colon means is that we are suggesting that func is a type of callable, and we'll also say that inputs is also an NP multidimensional matrix, and we also need to take delta, which is really a float kind of variable, which we explained that it is really a very small number, which is almost 0. And it gives out, this deriv function has all these arguments, and it gives out a multidimensional matrix. So if you are not really understanding what all these things are, it's okay. So it's just a first step, and you'll get used to it once you practice them and follow the tutorials. So in my lecture 2, I actually wrote out what these derivatives look like. So inputs plus delta minus func, inputs minus delta. If you're not understanding this formula, just go back to lecture 2. I've already given it, 2 into delta. So in a function, this I've already given a delta. So while calling this derivative function, if I don't really give the value of delta into it, so then it will take by default it will take 0.0001. Okay, so we run it. So it is successful. So while calling this function derivative, we don't have to write this callable this types, okay, after whatever there is in the semicolon. These are only suggesting to you that func is a callable which takes a multidimensional matrix, gives out a multidimensional matrix. Input is also a multidimensional matrix, and delta is float. What float means is a decimal. These are really decimals, real numbers. Okay, so let's get started. Let's take some values, which is np.arrange. What this function does is that in the NumPy package there is a function called arrange. Okay, so it will take some. This is the start, that is -10, and this is the end, this is +10, and these points will be spaced by some 0.01. What this means is that please give me a range of values from -10 to +10, and all those values should be separated by 0.001. It's really simple. So we will just see how this a looks like. So it is -a and dot. What it means that there are a lot of values. There's a lot of values. Okay, from -10 to almost +10. Okay, and now we will see like how what is the size of a. We'll just type a.shape. That is 20,000 values from -10 to +10, equally spaced values from -10 to +10, which are separated by 0.001, and there are 20,000 values to us. So now we will calculate the sign of these. This is really kind of this x like these. We will plot this a as x-axis. So let me just for convenience just name it as x. So we will just call np.sign. This is the sign of these x. So what this does is that in each values which are contained in x, this sign function is added to it. Okay, so let's see s. So s is ranging from 0.5 to -0.54. Yeah. So now we will just also calculate the derivative of s, that is ds dx is equal to deriv. So first, what is there? This is a function. What is our function? Our function is np.sign, right? So we'll give np.sign, comma, and what is our input? Our input is only x. Our input is only x, right? Like the func, the arguments of func, right? Which is an n-dimensional array. It's really simple. Yeah. Now I'll show you that what is the derivative of sine. You know that the derivative of sine is a cos plus cos. So we'll just plot it. We'll write plt.plot. First we give the x-axis. First we'll plot the sine, and then we'll just plot the x-axis and the y-axis, and put label as we can also use plt.use.style. I'll just use a new like a fancy style which will make our plots very beautiful. Okay, label, I'll give label as sine, and now we'll plot the derivative also. The values of the derivative are stored in ds dx, right? So we'll plot ds dx, comma, label as ds dx, right? And then we'll do plt.legend. We'll give some legend so that uh, location is equal to upper right, upper left, sorry. So we'll just give these labels in the legend, and it will show us nicely in the plot. Okay, plt.style.use. Yes. Yeah. So you get it right. So I'll just show that this blue line is the sine function, and the derivative of sine is really cos, right? So so here at 0 you can see the sine value of 0 is 0, right? And the derivative of sine has reached 1, and this is really the cos function. And it's really awesome that we can find out the derivative very correctly. So what we have learned is that how to import packages in Python, and also how to write functions. So functions, Python functions start with def, then the name of the function and some attributes, that is the inputs to the function. What are the inputs that is needed in the function. And we have also learned to type our different types of the attributes, how to actually write different types of attributes inside the function to suggest to the readers or the users to that okay, you know, these inputs are really a multi-dimensional matrix, so don't put any ints as inputs, or else it will throw out an error. Maybe it will throw out an error. And we can see that delta has, while coding derivative, we can always give this as 0.005. It will just take in that this value as delta, and if you don't really give anything, then delta will take the value of 0.001. And what is the output? The output of the function is also a multidimensional matrix, right? And then while returning, what this means is that, suppose we say that ds dx is equal to derivative of this, right? So what this means is that this func will take np.sine, the inputs will take x, it will calculate and return this value, it will calculate this and return this to the variable ds dx, correct? Yeah. So after that, we also learned how to plot our function. So we have used a style called 538, and at first we just plot the sine of the x, which was the blue line, and then we plot the derivative of the sine, which is really cos function, correct? And then we added some legends and we showed the plot. So this is what I wanted to teach in this tutorial, and let's see what is there in the next lecture. And we will start with forward pass and backward pass. So it will be really awesome. I think you'll like it. And this derivative will be needed in each step of that tutorial also. And let's roll on.